Okay, now we're getting back to real work. Okay, we have some heads. Joe made some decisions. What were those decisions, Joe?
Not just decisions, command decisions.
The only thing I heard was do whatever the hell I want and get it done. I think that's what he said.
Nope.
But he wants to use these expensive manly parts over here.
He wants the breather. The new that's going home.
He doesn't want to use these junk Harley valves. We're going to use those good lifter crane lifters and crane cams. A hot rod.
What else is in this box? That's just the charging stuff. Huh?
My regulars in there somewhere, or box. You're going to use a stock intake manifold, so we're not going to make these big. But I might accidentally cut the bowls out because he said he wanted to do a good valve job, not a cheap valve job.
Was it 3-cut?
And then we got the we're going to put the Elebrock Wiseco Tatro pistons in the stock cylinders.
We need to measure those cylinders for one of these days too.
So we need to measure them one of these days. So go get the mics. You know where they're at.
I know.
They're in the drawer.
Here?
I don't know. They're in the drawer. Not that drawer.
That's not mics, is it?
How about that
Is
drawer?
that what we want? For the piston?
What's a mic?
This one?
What's a mic? Is that a mic?
A micrometer.
A micrometer?
Inside or outside?
Yes.
That's an outside.
There's two of them there.
This one's for 4-inch, for a 3.5-inch piston. This one.
One's bigger in your hand,
This one?
less in your head.
You'll probably get that one.
That one there?
What is this thing? The world's smallest drill index?
That's not the world's smallest. That's just a normal drill index. It has drills in it.
Awfully tiny.
Well, some people work on big things around here.
I had some of these for working on jet engines.
Mm-hmm.
There's about 7 of them in one box. I got the Navy threw it away.
Mm-hmm.
I took it to the big 3 swap meet. It sold within 3 minutes of me getting out of the truck.
You did? Somebody wanted it, huh?
Yep. I couldn't believe it.
What were they measuring? 3-foot diameters?
They're made for measuring jet engine stuff.
Oh. Must be some
They had They had these little things to calibrate them.
Oh.
Going between them all and everything. Really nice setup. Home made by Stair.
You got $5 for it, huh?
Oh, that's the one we needed. One we did.
Yeah, hold on, sir.
Piston, huh? Okay, that's a micrometer that's also?
This is called a micrometer.
Inside?
Made in Japan.
Mm-hmm. We don't advertise that.
By me, Studio. So we don't like Jap parts, or Jap bikes, or Jap cars, but we do like Jap tools.
Very good, precise stuff.
As long as they're measuring tools. Not into other Jap tools. So we're favoritism.
What kind of number are you coming up with there? Are you checking for roundness?
That one just fell right through on this side.
Mm.
So it's bigger than what this one was. So in your case, it wears front to back, but you're tighter front to back. You're bigger side to side.
Why is that?
Because it's not round.
Aluminum barrels with steel inserts don't stay
Thin
round.
ass steel inserts, crappy aluminum cylinders means cylinders are not round or true. If they were made out of cast iron,
But why would mine be wearing the opposite way they normally do?
because it's not round. It warps when you put heat in it. And stress. I'm stressed out too, can't you tell? Okay, that's standard bore.
Okay.
See how it's 2,000 underneath the number?
I don't even get which number.
3.5.
I'm seeing almost a 5. Okay, 24 now. That'll give me a lesson later on how to read that.
2 lines down means 2,000 less. So
Okay.
you got 0. See how it says a big 0?
Yep.
Then
Where's
you
the
got
2
1
lines
and
down?
2 lines down is 2,000 less.
Okay.
That'll be 498.00. That would be called standard bore. Now this one here is bigger. You can see it won't go through. So
What's the difference?
so that means you have to open up the clamp a
4
little bit.
lines?
You have to make it clamp out a little bigger.
Not on the end very good down there.
Doesn't matter in between the flats. So you got drag on there. See that drag?
Yep. With 4 lines?
So now we are what number?
the same, isn't it? 22, 23? I don't know.
It was 2 full lines down. How many lines down is it now?
I don't know. I don't know what you're talking about. You told you to give me a
You have to
lesson on
look at
that.
your screen.
You have to give me a lesson.
Well, it's not hard to see lines.
I don't know how to. I can see lines. I don't know which one am I supposed to be looking at.
The ones in the round
That one
part.
right there, right? That straight line?
Yes.
Okay. And
How
then
many
what?
lines you got?
Got one straight one right there and a whole bunch going this way.
How's my titty? You're looking at you filming my titty.
Sorry, I'm trying to get my eyes in there.
Your eyes are supposed to be looking through the camera. So you see the 0 over there?
Yep.
See that big line right there? That's 1/1000.
Okay.
See that big line way over there? That's another thou.
So we're less than.
See this vertical line right here?
Yep.
That's your 0 point.
Okay, so we're at what, 23?
Well, you were at 23, now you're at 23 and more. Because see, now it's closer to 24 than it's 23.
That is going larger than, huh?
So you're 3/4 of a thou bigger now. So you're 3/4 of a thou out around on the cylinder. Which
Should we
means you
check
have,
the bottom?
which means you have 3/4 of a thou more clearance than standard.
Mm-hmm. But it's wearing in the opposite direction you said normal, though.
That's right.
And that's because the barrels are not round?
Because it's not round.
Since day one?
Since today.
Oh.
Now if you go look at this mic, and you see that this one says 23.5, roughly.
Okay.
It's more like a third.
Right.
So that means these mics are off by 4/10 of a thou from each other, 3/10 of a thou.
Japanese versus American.
Well, the mics are not the same. They never are. That's why you always use a standard mic. In that case, that's our standard mic. Okay, that one is a 1/3 of a thou tighter than standard.
Tighter than standard.
Tighter than standard. And that's on the side to side. So what's that mean? Taper, how big? 1/3 down and 3/4 up is 1.1 thou.
Okay.
Taper.
Taper. You want taper?
You don't want anything. You want perfectly round, true, and straight with a good finish to it. Now the bottom appears to be pretty round because it's about the same number again. So it's a little tight on the bottom. And I'm not measuring at the very bottom of the skirts, I'm measuring in a cylinder.
Mm-hmm.
Because the skirt up here doesn't really matter.
Right.
Now you can see all those deep scratches in there from your material. That was from your solid lubrication that was going up and down.
Solid lubrication.
Solid lubrication, not liquid lubrication.
Right.
Solid lubrication. Okay, so that one there is used.
That's where it is.
It's used.
For 65,000 or
That one just filled
66,000.
right through.
So that one,
That
no?
one's tight. See?
Same thing.
See how it's tight?
Side to side's good and other side's...
Front to back's tight. And on the bottom. It's a little tight there too. See, it's a little tight right there. So did I move the mic, or
Did you have to spread it a little
or
bit?
just smaller? Well, it might have moved on me. No,
And
it's
it got tighter, didn't it?
it's a full 1/3 down. It's almost 4/10 down, so it's a 1/10 tighter yet, and it still is tight because it didn't go through the hole. So this one's tighter than that one.
That's the front.
So the front one is tighter than that one on the bottom.
So
Now up here on the top is really loose right here.
the rumor is true, then the front cylinder runs cooler than the back one?
I didn't say that. Well, then theoretically it should be worn more than.
It should be worn more?
If it's a smaller fit, it should wear more than one that's loose, right? So that's exactly opposite of what you just said. So that theory went out the window. Okay, so we're 1/3 of a thou tight.
Boy, I mean, barely
Side to side.
barely a third.
So now we go over here. We're tight again. Tighter. So this is really tight front to rear on this one. Checking a different spot. It's definitely tight. So this one is almost
Right on almost, isn't it?
almost a full thou tight.
A full thou.
Full thou tight.
That's a good thing, though, isn't it?
Not if you want to run it fast, a high RPM motor with a lot of heat in it.
Oh.
Good way to stick a piston.
We don't want that to loosen up a little bit with the boring bar,
So
with the hone, huh?
That cylinder runs hotter than normal because it's in the front. Or is it colder than normal because it's in the front?
I've heard the rear one was.
has a smaller bore in it than the one that's in the back and it's real hot.
You'd think the rear one would run hotter,
Which means it would grow more.
but it's not true.
Which means it would wear less because the piston's the same size, theoretically front to back. Now we didn't check the piston yet, see if they're the same size yet.
Pistons are at my house.
So right off the bat, these need to be worked on a little bit.
Yeah. I was thinking that was coming up.
So that means you got plenty of room to hone right now, because they're tight. Now,
Not bad for 56,000 miles. My
are these
fancy
at room
piston.
temperature? Are these at room temperature like everything
I would
else?
say so, yeah.
Have they been in this room securely positioned for a while now without changing
Well, I
temperature?
think since a couple days.
Oh, okay. So now you measure these. Are they tapered or barrel shaped? They're tapered. Yeah, I know they're tapered.
Because mice getting loose is the higher you bring it, right?
It's bigger on the bottom than the top.
They're bigger on the bottom. But yeah, they're not supposed to go and drop in from the top anyway, right? They should only go in from the bottom of the barrel.
A lot of times they get tight right in the middle. They're barrel shaped, like they
Mm.
go like this. But these ones are actually bigger on the bottom.
How about a
You're
sideways
supposed to
measurement?
measure about a ½ inch down or a ¼ inch down, depending on what the manufacturer states. So right now we're at 21 1/3.
Can you measure 21 1/3? Okay.
21.3 thousandths.
21.3 thousandths.
That
Can you
was-
measure right below the ring?
Now we're going to measure this
The
one.
oil ring? Can you measure it the same way?
No, you don't measure there. You measure right here. See if it's tight at the bottom again.
That's a good thing.
So now this is a crappy manufactured part. Look at the difference in numbers.
It's the same.
Oh, okay, a good quality part, excuse me.
I don't have my eye. Same thing? Both
Same.
of them? I just want to get a measurement on right below the oil ring just for the
that
hell of
means
it.
they actually cut them the same diameter.
It's nice. Pay extra for
They
that
must
shit.
have screwed up and not fucked up like they normally do.
Pay extra.
So,
They come with piston clips and
now
shit,
you
ring,
take-
the ring
so
clips,
now you take this number here,
which is
21 1/3,
okay,
and our loosest number was 23.8
okay.
or 7.
This is 21.3.
And you get to take the difference between those two numbers, and that gives you a number.
I need a pencil.
And that'll give you the tolerance of how much your piston clearance is.
Okay.
Well, you can't count.
There's too many numbers for my brain right now.
You lost track.
21.3.
Well, you got a thing right here. See how it says 21.5 right here right now.
Yeah.
So if you go 1, 2, how many times you gotta go 1, 2 until you get to 23 from 21?
2.
Ooh,
So that's 2,000.
plus another third or so. 4 tenths.
.003.
Plus another 4 or 5 tenths extra.
You got to write it down too. I know you got
So
to get all
that's
that in your head.
2.5 thousandths or 2.4 thou or something like that.
Okay. What was the other one?
Well, these pistons are made to go in a standard hole to have your clearance. That's what they're supposed to be.
I know, but you said we had to get a number out of.
So if you're supposed to be at a standard hole at 21 to 22, 23, that means you got 1.5 thou clearance if they want to put that in there at.
It's enough for you? You be happy with that?
Nope.
What, you like to be sloppy?
I like to go down the road without worrying about my pistons sticking.
Yeah, me too.
Now, what did we do wrong? Well, the first thing is we did not measure at the very tip. We measured up from here, which is a bit bigger. Because that tip is going to disappear pretty quickly.
For Edelbrock heads.
So, and you're supposed to be 2 to 2.5 thou clearance. So I got 2.5 on your loose side.
Okay.
But on your tight side is 1.5.
When it's tight?
And I didn't measure at the very base of the screw, which is probably going to lose. It's probably going could be another 1/2 thou less clearance than that. So basically like 1 thou clearance. Which is not what I want.
So you're going to have to hone it and make it right?
And
Or
so
what?
how much is our clearance? We were at 21 1/3. I could probably go 21 1/4. So I go 1, 2.5. So we're 2.5 on your loose number.
What number?
2.5 on the loose number.
Loose number, okay.
Like I said, we're a thou quarter or so on the tight side, on your tight number. And we're supposed to have 2 to 2.5.
Right.
And I was at the base of the skirt, which we didn't measure there. I measured below the base.
But you should have been a little bit
So that
bigger
means
at the
you
base.
so that means you're gonna. It's gonna be another. Be a little bit bigger again.
Yep.
What's it at the very tip? Couple tenths difference. Not quite a quarter, but a couple tenths. Noisy.
All right.
So that means you drop down to 0.9 to 1 clearance
Clearance.
on the tight spot. Maybe a little snug. So if you put these together nice and loose, it'll rev up a night quicker and easier and not quite be so hot.
No, we don't want them sticking down going down the freeway either.
If you want them nice and tight, it'll run hotter and sluggish because there's more drag.
I don't want that.
Make more heat.
I'd rather have them loose.
Be quiet until it sticks. Then it'll make noise.
I rather see those pistons after 50,000 just have a couple little scars at the most on them.
Put them in there 3 or 4 thou clearance, and you can hear them a lot rattling there.
Yeah.
It'll go even faster because it's got less drag on it yet.
But.
It's got that racing clearance in there.
But.
Well, the ring seal might drop a little bit because it's walking around so much.
Yeah.
So you might have that a little more leak down, so your horsepower might drop slightly. So you gain from drag. You gain from less friction, but you lose because the rings don't seal as good.
Right. So happy medium would be somewhere in
There's
between
a
that.
trade-off in there somewhere.
I'm sure you know it.
Well, it's probably somewhere between that 2 to 2.5 number, but if you're gonna drive it really hard, that could be 2.5 to 3 for racing.
Well,
There you go.
let's hope those pistons aren't too much compression for
So
the
what number you
like,
want to
handles.
use?
Huh?
What number do you want to use?
025. 0025.
From what?
The clearance.
Oh. So that means if we go from that number right there, we go to 1/2 thou, and we go 1 and 2. And we're at what number? We're at our loose
0.
number. We're at our loose number.
That's 2 loose number though?
The 23 and a third, or 2/4.
Hmm.
So that means I gotta hone these out until our biggest part we measured is gonna be our normal.
Where's that that measuring device you use to do the cylinders when you're honing them? Kind of like, nah. You have something larger. Kind of stick it in there and while you're doing the hone. Similar to that.
Well,
but
this is the one you use for this. The one in the drawer, the other one's bigger, is for the other cylinder. This is the one I use for this motor.
I don't know. Ain't the one I've seen you use when you're honing the cylinders at the time. When you're actually doing the honing and you check the nah. That's something with a handle on it, like it had a handle. No? Bullshit, dreaming?
You're watching someone else's video that using a dial bore gauge.
That's what it is. Then now you know what I'm talking about.
Do you see a dial bore gauge anywhere in that drawer over there?
I don't know. No.
Well, maybe I'm not using a dial bore gauge.
But you do when you're doing this honing, don't
You
you?
know why people use dial bore gauges?
To get it straight.
Because they had no scale requirements, so they all use a dial bore gauge.
Is that easier? That much easier?
Yeah.
All right.
You've taken out the feel part, what the drag is going to be. You get an average number between 3 buttons instead of straight across, where you get an exact number, you get a 3 number deal. To stabilize it off the pin.
So not for the real racing motor.
It's quick and simple. Doesn't make it better. Could be slightly worse. It's not quite as accurate, but debatable about that. If you know how to use your tools, they're both pretty accurate.
And what's it going to take to get the valves
It's just if
working?
you don't know how to use your tools, it's a deadfall easy system to use. So.
Well, I learned how to use the tools, just how to measure, how to read them at all.
But the big thing is how do you set it?
On the other thing, the other
How do
tool?
you set a dial bore gauge accurately?
I don't know. Similar to that thing?
Well, they're going to tell you to take that mic and put it onto a 3-finger device and measure it.
Can't with 3
I
fingers.
take a 2-finger, put on a 2-finger. I know it's accurate. You take something that goes off 3 fingers and try to use 2 fingers on it. It doesn't work quite the same.
Not even close.
So you're supposed to use a ring gauge.
About the rings, we got new rings?
There's a drawer around here, ring gauge. My drawers keep moving on me. gauges. These are ring gauges.
Okay.
This is 1.750 plus another digit. So it goes out 4 tenths. So this is 10 thousandths of an inch. And you can guess it to within 50 millionths, which is 6 digits out. So these will grow and shrink by temperature like everything else in the world. So this is a 2-finger dial bore gauge.
Mm-hmm.
So everything like that. And that's how you set it. You can see how it's not the same as it was last time I used it.
That's a calibration device.
It's called temperature change.
Really? That much difference, huh?
Almost 2 tenths of a thou. That's 1 3/4
Should have been right on 0 then? Last time you used it?
Now if you go turn this to 90 degrees, checking your tool accuracy, see how now it's a little bit bigger?
Yep.
Because this gauge now has half a thou of air in it. And every tool has air, it's just a matter of what degree of air you have. That's why you pay more money for more accurate tools.
Wow.
So this one here is a variable. See, it has half a thou difference in it.
So that's just a calibration device then?
Just a calibration device. This comes off 2 fingers, so it's pretty accurate. 3 fingers I don't like at all. Not as accurate. I use this for main bearings and stuff like that because it's too hard to do a mic that small. My fingers are too damn big. So that's why you don't do it that way.
We're in the specialty tool drawer tonight, folks.
This thing's on my way too, so it goes down there.
That Mitsuyoki thing down there?
And you got little small ones for doing valve guides.
Oh, wow. The black Mitsuyoki, that's the fanciest
And then you got big ones
measuring
here for
device
doing,
we have.
Then this one is for doing
Did you make that
twin
one?
cams.
You make that one?
I might have made this one. And see, it's plus 2 tenths because it's not quite accurate. You know why it's plus 2 tenths?
Because not as accurate.
Because I honed it too big.
Okay.
It's hard to put metal back.
Yep.
I was trying to get a better finish and it kept growing every time I honed it. What's up with that?
That means it's getting larger and taking away metal.
So
There you
this
go.
one here I don't use very often. See, it's a 1 3/8.
Okay.
More accurate tools. All right, so what do we got to do now?
You hone them cylinders.
We got to hone this. We got to open up these stock cylinders to our standard bore pistons.
Yep. What about the our ring gap?
It said there was supposed to be a ring gap in the box. I think it said 16 thousandths.
Nice pistons.
How about a pin gap?
No pin gap.
There's a pin gap.
Yeah. Not much.
It's the end play between the snap rings.
Oh.
It's supposed to be pretty tight. Less than 5.
Really?
Yeah. It's supposed to be. It's not. It's more like 10 to 15.
Oh.
And then you got a clearance, which how much clearance you got in your pinhole.
That's what I was thinking you're talking about.
That should be 8 tenths to 1.2.
And then you got the rod.
That should be 8 tenths to 1.2 thou.
What about the rod bushing?
Same clearance. Supposed to be. What's your clearance of that rod over there? How loose are your rods?
I have no idea. Oh, the rods were in good shape.
I know I'm not going to fix them unless they're really trash. You don't have to be taking your motor for it,
Right.
which we don't want to do.
We don't want to do that when we get an Ultima.
So where's your checking wrist pin at?
I don't know. We're in the wrist pin checking box. There it is. Not that one?
Which one do you want to use?
The one for the Evo.
Evo.
Is that it? What's that line mean? Shovel head?
The Evo.
Huh.
This is shovel head. No line. Every few years I got to change these out because they get worn.
Really?
Yeah.
Doing a lot of shovel head work then, huh? Okay, look at that lower end. Nice, 60,000 miles. There's a little oil on the bottom. I gotta just get it out of there too. Pretty tight.
They are tight. You'd have to get the grit worn off. Still snug.
Just like the lower end bearings.
Not quite a slip fit.
He said the other night, the best engine that Harley ever made right here. Off video though.
The best crank was 1986 to early 89,
Huh.
which is this one. because it was balanced correctly, which is the only time they made a big twin balance correctly, which is at 60%.
Is that because the Germans were involved in it?
But the problem is the flywheels are trash for material. They don't stay around very good.
Yeah.
So where's your other wrist pin at?
We try it. Again. Getting the crud off of it?
Yep.
That's how they wear, huh?
Let me go where slides first. See? That's the fit I like using, see? Supposed to drop through.
And it's not because of what? It's a little dirty?
On a race bike, it doesn't even slow down at all.
Really? That loose, huh?
You just go straight through.
Yeah.
On a street bike, you want to have it where it just goes through slowly, but it goes through. So not like this. That's got a little drag. But see, this is my checking pin. It's not the actual one we're using.
Right.
This is the one we're going to use. You know why we're going to use this one?
Why? Because it came with the piston.
Because it fits.
Oh, short, yeah.
Looking over here. Looking over
Yeah, I
there.
got it.
Lighter pin, less vibration. Same thickness. It's going to be lighter. It's going to vibrate less.
And that's what we want. Tight.
It's got to stick them on it.
Right from the bag. Don't put that dirty thing through my pistons.
We didn't clean it. You can spit on it, clean it up a little bit.
I don't know how you do it. Rag, clean rag. Watch out for some microfibers might stay on there.
Microfiber towel.
None of the head studs, exhaust studs were broken or nothing. That's good.
Clean that up. Somebody would feel like goo through the piston.
Not heavy enough to go all the way through like the other one did.
Well, somebody still got goo in the piston.
That could be.
Well, I know that. You got to put the gooey wrist pin through it already. Put this one through there. Clean it up a little bit.
Getting better.
Geez, it's the same size as mine.
Still some goo.
It's the same size as my checking.
Oh, I just made that one.
This section genuine Harley wrist pin.
It is? Why is it so wide? Big bore?
That's how they made them back then. Alright, so that's the same clearance.
Don't throw it in. You can ding them pistons up. Ding that pin up.
Don't ever do that again.
Man.
I'm gonna get rude comments about that again. Then I'll have to go.
He won't even let me touch a cam with my fingers, but he'll throw around them piston parts.
That's right. And I'll take this nasty pin and throw it in this drawer right here and not even care about it.
And stick it in somebody's brand new Wiseco.
Yeah.
All right, folks, we'll get back to you.
All right.